In section 11.6, we're going to look at Pascal's triangle, and we're going to use Pascal's triangle to do something called binomial expansion, to multiply a binomial to a power. So with Pascal's triangle, what we have here is 1's going down the sides, and then to fill in each of the spots, you add the two numbers above it. So 1 plus 1 would be 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 should be 4. And then you have your 6 and you have your other 4, right? And then 1 plus 4, that should give me 5. And then you have your 10, your 10, your 5. And each row continues by adding the two numbers above it. And Pascal's triangle does continue on and on, but for our purposes, for the first two examples, this should be pretty good for the portion of Pascal's triangle that we'll be using. So let's go to example 1 and let's look at how we're going to use this triangle, Pascal's triangle, to do a binomial expansion. This is a binomial 3x minus 2y, and we're raising it to the third power. Okay? So when we go through and use Pascal's triangle, this would be what we're going to use when it's the first power, second power, third power, fourth power, and we just keep going down. This would be fifth power, sixth power, and seventh power. Okay? So this is a third power, so I'm going to use this line right here. 1, 3, 3, 1. So if I go 1, and then I'm going to put two parentheses, and then I'll do plus 3, two parentheses, plus another 3 here with two parentheses. And I'm going to take my triangle here, Pascal's triangle, and move it down. Okay. And then we have the last number, which is 1, and then I'll have two parentheses. So all I did was use the numbers in row 3 and put them outside the two parentheses. Now the first one is going to be your first term. So this will be a 3x and a negative 2y. 3x, negative 2y. 3x, negative 2y. 3x, negative 2y. Now the powers are what are important. We start with the first term here with a 3 as the exponent and a 0 on my second term. And then we decrease the first term's exponent 1 each time. So this would be 2, 1, and 0. And we increase the second exponent each time, which would be 0, 1, 2, and 3. Okay. So now we should be able to multiply each one of these out. So this is 1 times 27x cubed, and then negative 2y to the 0 power is going to be 1. So that's what I ended up with for my first term, and then we'll simplify down in a minute. This would be 3, 9x squared, and negative 2y. And then the next one would be 3 times 3x times negative 2y all squared would be a 4y squared. And then this is going to be 1. 3x to the 0 is 1. And then a negative 8y cubed. So now let's go through and simplify this whole expression. This would be 27x cubed. We would end up with a negative 6 times 9 would be negative 54 x squared y. The third term here would be 9 times 4 would be 36 xy squared, and then minus 8y cubed. So if I expanded the binomial, if I did 3x minus 2 times 3x minus 2 times 3x minus 2, this is what you would end up with when I multiplied those out. And it's probably easier to use binomial expansion. I know it is definitely going to be easier as that exponent increases from 3 to like 7 or 9 or 6 or whatever it turns out to be. It's a lot easier to use the Pascal triangle. Okay, let's try one that's a little bit bigger. How about 2a minus b raised to the 6th power? That's 2a minus b times 2a minus b times 2a minus b 6 times. So since my exponent is the 6th, this, remember, is the first power. So 2nd, 3rd, 4th, 5th, 6th. This is the line that I would be using. Okay? And I'm going to slide that off to the side now, or I'll drop it down here. So I have a little more room to work. This would be 1, put your 2 parentheses in. And then you got 6 with your 2 parentheses. And then you have 15 with your 2 parentheses. And then you have 20 with your 2 parentheses. And I'm going to run out of room here, so I'll bring it down here. So this will be plus 15 with your 2 parentheses, plus 6 with your 2 parentheses, and then plus 1 with your 2 parentheses. And since we started with a 6th power, this would be 6, 5, 4, 3, 2, 1, 0. And this one would be 0 and going up. 1, 2, 3, 4, 5, and 6. In the first parentheses, I have 2a. Second parentheses, I have negative b. And now we have to evaluate. So this would be 1 times 2 to the 6th, which would be 64, a6, and then negative b to the 0 is just 1, plus 6 times 2 to the 5th would be 32, a5 times negative b, and then 15, 2 to the 4th would be 16, a to the 4th, negative b squared, negative b quantity squared would just be b squared. Then we end up with 20. 2 to the 3rd is 8, a to the 3rd, and then negative 1b cubed would be a negative b cubed. We're down to 15. 2 squared is 4, a squared. And then negative b to the 4th would be a positive b to the 4th. Negative 1 to the 4th is 1. B to the 4th is b to the 4th. And then 6 times 2a. Negative b to the 5th. Negative 1 to the 5th is still negative 1. And that would be b to the 5th. And then my last term would be 1 times b to the 6th. A negative 1 to the 6th power is a positive 1. B to the 6th is b to the 6th. Okay, so let's continue to move things down. And let's simplify. First term is going to be 64, a to the 6th. Next term would be 6 times 32 times negative 1, which would be a negative 192, a to the 5th, b. The next term would be 15 times 16. That'd be 240, a to the 4th, b squared. And then I have 20 times 8 times negative 1. That'd be a negative 160, a cubed, b cubed. And then I have 15 times 4, which would be 60, a squared, b to the 4th. And then 6 times 2 is 12 times negative 1 would be negative 12, a b to the 5th. and then b to the 6th. And this is what you end up with when you have 2a minus b raised to the 6th power when I expand that binomial using Pascal's triangle. Now, all of your homework is not going to be this in depth. Some of the problems will just say, what is the 5th term of x plus y to the 10th? So if I'm going through, again, I'll use Pascal's triangle, the 5th term of a power to 10. So remember, this is your first power starting on the 2nd line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the row I want right here. If I'm looking at the 5th term, I'm looking at 210 as the number out in front. Okay, and then I have my 2 parentheses. Well, in this one, if I start with the 10th, raising to the 10th power, the 9th power, 8th power, 7th power, this would be to the 6th power. And if that's to the 6th power, this has to be to the 4th power, because together they have to add up to the 10th power. Okay? And this is an x, and this is a y. Those are your 2 terms of your binomial. So your answer should be 210 x to the 6th, y to the 4th. So that's a little bit easier than that big long process that we just went through in example 2. Let's try one more of these. How about we find the 7th term of 2x plus 3y to the 8th power? So this is your first power again, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. So we're using this row, and we're finding the 7th term. So that would be starting with the 28 right here. Okay. And if I want the 7th term, that means that I had an 8th power, so 8, 7, 6, 5, 4, 3, 2. So if this is 2, this would have to be 6. 2x here, a 3y here, and we're ready to evaluate. 28, 4x squared, and this would be 3 to the 6th, which I'll do on my calculator here. That's 729, y to the 6th. Okay, so 28 times 4 times 729, 81648, x squared, y to the 6th. So that is the binomial expansion of 2x plus 3y to the 8th power. The other thing that we go through and talk about here is factorial notation. So whenever you have a number and the exclamation point behind it, that means factorial. So 4 factorial means 4 times 3 times 2 times 1. Or 4 factorial is equal to 24. 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1, which if I multiply those out would be 720. So just here's a basic chart of the n value and what the n value to a factorial would be. And as you can see, it grows very rapidly because we're increasing by a larger and larger integer each time. So when you are evaluating expressions using factorials, this is kind of a neat little activity that we can go through and do. I could, in this case, write out 7 factorial and 4 factorial. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial would be 4 times 3 times 2 times 1. I could write that out if I wanted to, but there's a little bit easier way to simplify. 7 factorial was 7 times 6 times 5 times 4, and then times 3 times 2 times 1. Well, 4 factorial is 4 times 3 times 2 times 1. And I stopped at 4 factorial because I have a 4 factorial on the bottom. So now notice 4 factorials drop out. So this expression is actually 7 times 6 times 5. 6 times 5 is 30. 30 times 7 is 210. So that expression equals 210. Okay. Let's try another one here. factorial, 12 factorial. That's 12 times 10 times 11 times, or 12 times 11 times 10 times 9 times 8, so on and so forth. What I'm going to do is I'm going to write 12 times 11 times 10 times 9 times 8 factorial on top. Because I know an 8 factorial is going to cancel with 8 factorial. So those will drop, leaving me 12 times 11 times 10 times 9 divided by 4 factorial, which is 4 times 3 times 2 times 1. Okay. I know 4 times 3, that's 12, so that 12 will drop with the 12 up top. And a 2 can be taken out of the top and the bottom, leaving me a 5. So what I end up with is 11 times 5 times 9 all over 1. 11 times 5 times 9 will end up giving you 495. So these are quick and easy ways to go through and evaluate factorials. Okay? And that will conclude the notes for section 11.6, dealing with binomial expansion and factorials.